I've dedicated my entire life to understanding the cosmos. I've written books about the future of humanity, the nature of consciousness, and the fundamental forces that govern our universe. I've stood at the world's most powerful particle accelerators, gazed through the lenses of our greatest telescopes, and wrestled with equations that describe the birth and death of stars. But nothing, and I mean absolutely nothing, has shaken my understanding of reality quite like what we've just witnessed with the interstellar comet. Designated 3I Atlas. Let me take you back to where this story begins. It was a Tuesday morning when I received an encrypted message from a contact at the European Southern Observatory. The message was brief, almost cryptic. Michio, we need to talk about 3I Atlas. Something's wrong. Very wrong. Now, I get messages like this occasionally, excited astronomers who think they've found something revolutionary. But this colleague, Dr. Elena Vasquez, isn't prone to exaggeration. She's one of the most methodical, careful scientists I know. When she says something is wrong, you pay attention. The interstellar comet 3I Atlas was discovered only months ago, the third confirmed interstellar object to visit our solar system after Oumuamua and Borisov. At first, it seemed unremarkable by astronomical standards, just another cosmic wanderer, passing through our neighborhood on its eternal journey through the galaxy. But as our instruments tracked its path, as we gathered more data with each passing day, we began to notice things that didn't add up. Things that couldn't add up according to everything we know about physics. The first anomaly appeared in the light curves. When you observe a comet, you expect certain patterns in how its brightness changes. These variations tell us about rotation, about outgassing, about the object's shape and composition. But 3I Atlas was doing something bizarre. Its brightness was fluctuating in ways that violated the laws of thermodynamics. It was emitting more energy than it was receiving from the sun. Significantly more. We're not talking about a small discrepancy that could be explained by radioactive decay or residual heat. This object was producing energy as if it had its own internal power source, one that operated on principles we don't understand. I flew to Chile to work with Elena and her team at the Paranal Observatory. We spent sleepless nights collecting spectra, analyzing data, running simulations. The spectroscopic signature was unlike anything in our databases. Yes, we detected the expected molecules: water ice, carbon dioxide, simple organic compounds. But there was something else, something that appeared in spectral lines that shouldn't exist. We were seeing signatures of matter in quantum states that our textbooks say are impossible in the temperature and pressure conditions of space. Then came the gravitational measurements, and this is where things went from puzzling to absolutely inexplicable. Einstein's general theory of relativity tells us that mass curves space-time. This isn't just theory. We've measured it with exquisite precision. We know exactly how much a given mass should bend the path of light passing near it. We've used these calculations to find exoplanets, to map dark matter, to detect gravitational waves from colliding black holes. The mathematics is ironclad, tested, and verified 1,000,000 times over. But 3I Atlas was bending space-time in ways that defied Einstein's equations. When light from background stars passed near the comet, it was being deflected by angles that would require a mass hundreds of thousands of times greater than what we measured. At first, we thought our measurements were wrong. We recalibrated everything. We used different telescopes, different techniques, different teams working independently. Every measurement told us the same impossible story. I remember sitting in the observatory at 3 in the morning, staring at the data on my laptop screen, feeling a sensation I haven't experienced since I was a graduate student, first encountering quantum mechanics. It was a mixture of excitement, confusion, and something close to fear. The universe was showing us something that our most fundamental theories couldn't explain. Einstein's field equations, which have passed every test we've thrown at them for over a century, were failing to describe what was happening with this object. My colleague from MIT, Dr. Robert Chandler, proposed that we might be seeing evidence of quantum gravity effects. You see, physicists have known for decades that Einstein's general relativity and quantum mechanics don't play well together. At everyday scales, at the scales of planets and stars, general relativity works perfectly. At the quantum scale, inside atoms and subatomic particles, quantum mechanics reigns supreme. But at the intersection of these realms, at the Planck scale, where quantum effects meet strong gravitational fields, our theories break down. We've expected to see quantum gravity effects near black holes in the first moments of the Big Bang, but in a comet, that should be impossible. Yet the data kept mounting. We observed 3I Atlas affecting the trajectories of nearby asteroids in ways that couldn't be explained by Newtonian gravity or Einstein's corrections. We detected variations in the local fabric of spacetime that seemed to pulse, to oscillate, as if the comet was generating gravitational waves. But gravitational waves can only be produced by massive objects in violent acceleration, not by a relatively small comet in steady motion. Then we discovered something that made me question whether we were observing a natural phenomenon at all. The anomalies weren't random. They exhibited patterns, mathematical regularities that looked almost designed. The energy output followed a sequence that resembled a fractal pattern. The gravitational distortions had symmetries that appeared to be deliberately constructed. As a scientist, I'm trained to avoid jumping to extraordinary conclusions. I've spent my career advocating for rational, evidence-based thinking, but the evidence was pushing us toward a conclusion that sounded like science fiction. I convened a private meeting with some of the most respected minds in physics, including 2 Nobel laureates, leading cosmologists, and experts in exotic matter. We met at the Institute for Advanced Study in Princeton, the same halls where Einstein once walked. For 3 days, we debated, argued, and wrestled with the implications of what we were seeing. Could 3I Atlas contain some form of exotic matter we've never encountered? Could it be a natural formation from a region of space with physics different from our own? Or were we witnessing something else entirely? Evidence of technology, of engineering on a scale, and with a sophistication that would require a civilization millions of years beyond our own. The turning point came 6 weeks after our initial observations, when something happened that elevated 3I Atlas from a scientific curiosity to what I can only describe as a crisis in our understanding of reality itself. I was at a conference in Geneva, presenting some preliminary findings to the particle physics community at CERN, when I received an urgent call from NASA's Jet Propulsion Laboratory. They had detected something using their deep space network, the array of massive radio telescopes we use to communicate with distant spacecraft. Struck had just emitted a burst of radiation, unlike anything in our databases. This wasn't the thermal radiation you'd expect from a comet being heated by the sun. This was coherent, structured, almost like a signal. The frequency spectrum showed peaks at intervals that corresponded to fundamental mathematical constants. Pi, the golden ratio, the fine structure constant. To a physicist, seeing these constants appear in natural phenomena isn't unusual. They're woven into the fabric of reality itself. But to see them arranged in this particular pattern, in this sequence, it was as if the universe was speaking to us in the language of mathematics. I immediately flew back to California and spent the next 72 hours at JPL, working with their team to analyze every bit of data we could gather. We pointed every available instrument toward 3I Atlas, radio telescopes, optical telescopes, X-ray observatories, even gravitational wave detectors. What we discovered has forced us to reconsider everything we thought we knew about the nature of space, time, and matter. The comet wasn't just bending space-time, it was manipulating it in ways that suggested a deep understanding of physics beyond our current theories. Using interferometric techniques, we were able to create detailed maps of the space-time curvature around 3I Atlas. What we found was shocking. The object was surrounded by a region where the normal geometry of space was fundamentally altered. Inside this region, parallel lines didn't remain parallel. The shortest distance between 2 points wasn't a straight line. The very axioms of Euclidean geometry, which we take for granted in our everyday experience, were violated. Even more disturbing, we detected temporal anomalies. Time itself was flowing at different rates at different locations around the comet. Now, we expect this near massive objects. It's a consequence of Einstein's theory. But the degree of time dilation we measured was completely disproportionate to the comet's mass. In some regions, time was flowing at half the normal rate. In others, it appeared to be flowing faster than it should. And in a few small pockets, our instruments suggested time might be flowing backward, though this seemed so impossible that we're still trying to verify these measurements. Dr. Lisa Chen from Princeton's Institute for Advanced Study has been working with me on a theoretical framework that might explain what we're seeing. She's an expert in string theory and quantum field theory, and together we've been developing a model based on the idea that 3I Atlas might be interacting with the quantum vacuum in unprecedented ways. You see, what we think of as empty space isn't really empty. It's filled with quantum fields, with virtual particles popping in and out of existence, with a seething energy that underlies all of reality. What if 3I Atlas has found a way to tap into this vacuum energy to manipulate these quantum fields in ways that produce macroscopic effects? The implications are staggering. If our model is correct, 3I Atlas is demonstrating a level of control over fundamental forces that we won't achieve for centuries, maybe millennia. It's doing things with gravity, with space-time itself. That would require technology based on a complete understanding of quantum gravity, the holy grail of theoretical physics that has eluded us for 100 years. Either this is a natural object formed by processes we've never imagined, or it's something else entirely. I need to be careful here. As scientists, we're trained to follow the evidence wherever it leads, but we're also trained to prefer the simplest explanation that fits the facts. The problem is, there is no simple explanation for 3I Atlas. Every hypothesis we've proposed requires us to overturn fundamental assumptions about physics. The natural explanation requires exotic physics we've never observed. The artificial explanation requires accepting that we're not alone in the universe, and that someone out there has technology that makes our most advanced achievements look like stone tools. Last week, I testified before a closed session of Congress. Senators and representatives wanted to know what this means for national security, for the future of humanity. I told them the truth. We don't know. If 3I Atlas is a natural phenomenon, it means the universe is far stranger and more complex than we imagined, and we need to fundamentally revise our understanding of physics. If it's artificial, if it represents technology from another civilization, then we're faced with evidence that intelligence in the universe can reach levels we can barely conceive of. What keeps me awake at night isn't just the mystery of what 3I Atlas is. It's what it represents about the limits of human knowledge. Einstein gave us a framework for understanding gravity that has worked flawlessly for over a century. Quantum mechanics has allowed us to build technologies that would seem like magic to previous generations. We've split the atom, mapped the human genome, detected ripples in space-time itself. We've come to believe that, given enough time and resources, there's no mystery we can't solve, no puzzle we can't unravel. But 3I Atlas is showing us something Einstein couldn't explain, something our quantum field theories can't account for, something that exists outside our current paradigms. It's a humbling reminder that the universe doesn't care about our theories, our equations, our carefully constructed models of reality. The universe simply is what it is. And sometimes it shows us things that force us to admit how little we truly understand. The comet is now moving away from the inner solar system, heading back out into the vast darkness of interstellar space. We're tracking it with every instrument we have, gathering data that will keep physicists busy for decades. I've assembled an international team of researchers, the brightest minds from every relevant discipline, to study this phenomenon. We're calling it the 3I Atlas Project, and it may well be the most important scientific endeavor of our generation. I'm reminded of what the physicist John Wheeler once said. We live on an island surrounded by a sea of ignorance. As our island of knowledge grows, so does the shore of our ignorance. 3i Atlas has just expanded that shore dramatically. It's shown us that even our most fundamental theories, even Einstein's masterwork, might be approximations, special cases of deeper, more comprehensive laws that we haven't discovered yet. To my younger colleagues, to the students who will inherit this mystery, I say this: embrace the unknown. Don't be afraid to question everything we think we know. The greatest discoveries in science have always come from those willing to look at the evidence with fresh eyes, to consider possibilities that seem impossible, to imagine what others dismiss as unimaginable. 3i Atlas has opened a door, and what lies beyond that door may transform our entire conception of reality. The adventure is just beginning, and I, for one, cannot wait to see where it leads us.